Today we will be discussing chemical vapor deposition technology on a silicon wafer. Hexyl acrylate is vaporized and acts as a monomer, which is polymerized to the wafer surface. This reaction is initiated with the free radical group on cleaved tert-butyl peroxide, which breaks the hexyl acrylate's unsaturated bond. This allows for multiple hexyl acrylate molecules to continuously react to each other to form a polymer. The deposition rate will be measured by a helium-neon laser passing through a vacuum chamber to the deposited film, where it reflects to an interferometer which measures the laser intensity. A portion of the laser beam reflects off of the film, while some light passes through and is reflected off of the wafer. The beams of light reflecting off of the wafer and film are out of phase. They create negative interference, which lowers signal intensity read by the interferometer. As film thickness increases further, the offset in waves decreases and signal intensity increases. This leads to a sinusoidal pattern shown by the graph of signal intensity versus time. The thickness of the film can be calculated from the shown equations. Theta is the angle of the laser with respect to the normal of the surface. N is the refractive index of the hexyl acrylate polymer. Lambda represents the laser's wavelength measured in nanometers, and delta D film is the change in polymer thickness in one cycle in nanometers.
Now it's time to bring it around town. Bring it around town.
The results of each trial of this experiment are shown by separate graphs plotting interferometer signal versus time. Each graph shows 3 trials taken at identical filament and chiller set points, meaning the wave period and amplitude should be the same. Plotting the natural log of deposition rate versus the inverse of filament temperature creates a linear data trend with a slope equal to the negative of activation energy divided by the ideal gas constant. Our experimental results showed an activation energy of negative 45.7 kilojoules per mole, an error of 42.4% compared to literature values. The experiment succeeded in polymerizing hexyl acrylate to a silicon substrate. However, it was not able to accurately solve for reaction activation energy. This may have been in part due to physical condensation of hexyl acrylate in vapor form. During one trial, a glass plate was suspended over the substrate. This resulted in a thinner polymer film, which would not be the case with chemical vapor deposition as it only occurs on a surface level. In addition, stage temperature was not accurately read or controlled due to a poorly placed thermocouple. The filament temperature also was not digitally controlled, which led to inaccuracies and temperature fluctuations. These 3 factors would need to be addressed and fixed before retesting the experiment.
I'm a boss, 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 I'm a boss.
Then this, and this, then that, and this, and that, and this, and that, and that.
You guys graduate.